Okay. The first thing that they talk about is the number system in which you have natural numbers, then you have integers, whole numbers, then integers, then real numbers. Irrational numbers are any non-repeating, non-terminating decimal. So anytime you take the square root of a number that's not a perfect square, it becomes an irrational number. Now in grade 11 and 12, you don't want to work with irrational numbers. You want to leave them as exact values. So for example, when I have the square root of 5, instead of writing it as a decimal and having to round it off because it doesn't ever end, we just leave it as square root 5. Okay? Now we assign this a term called a radical. Now a radical is any square root value that cannot be broken down. Radicals can also be expressed as powers or fractional exponents. So one of the rules we had, the square root of x, let's say. The square root of x can be written in which we have a rational exponent of 1/2. All right? The cube root of x can be written as x to the 1/3. The fourth root, x to the quarter, and so on. We can write these out. Now, the rules still apply the same way. So if I have square root of x to the 5th, that's like saying x to the 1/2. Sorry, again. That's like saying x to the 5th to the 1/2. And then I have an exponent or a power to a power in which I multiply those together and I write it as one simple rational expression in which the exponent is a rational value, in this case a fraction. The index of the radical has the same value as the denominator of the fractional exponent. Index, this is what we refer to as the index. And all it says is that this value here has the same value as the denominator on the exponent. We've already done this. We talked about this in the very first day we did all of this. We talked about this. So that none of this is new so far. Radicals can be entire radicals such as a square root of 72, 5th root of 96, cube root of 54/8. It can also be
interruption. Jasmine Adair, Mark Wolf to the office. Jasmine Adair, Mark Wolf to the office.
It can also be mixed radicals such as 6 root 2, 2 to the 5th root of 3, and 3 root 2/2. You cannot convert between entire radicals and mixed radicals. You can order radicals that are irrational numbers using different methods, using the calculator and so on. So what that just said is this. What we're looking at today is writing them in two different ways. The first way, for example, if I have that, I would write that as 6 cubed to the 1/2, which is equal to 6 to the 3/2. It's one way in which we can write a radical. The second way, let's say I had, and this is new to you, no, I'm not quite there yet. Let's do it like this. 2 root 3. 2 root 3 is what we call a mixed radical, in which you have a radicand. You have a radicand which is underneath the square root, and you have a whole number coefficient in front. So that basically reads 2 times square root 3. Now instead of, again, writing it with decimals, we leave it as it is right now. We leave it as 2 square root 3. Okay? Page 75. So we're going to work through this, and then I'm going to get to the simpler way of doing this. Convert each of the following as requested. Express each power as an equivalent radical. So an equivalent radical. 32 to the power of 1/2. Is that correct? Okay. Now, how can I write that in terms of a radicand? So remember, the radicand has to contain a square root value, whether it's cubed or... So there it is. That's all I need to do for that. Just rewrite it as square root 32. Okay? That's simple enough. What about 16 to the 2/3? Go ahead.
Yeah, like cube square root.
Close? Yeah, you're on the right track. Okay? This value goes where?
That's the index.
That's the index, right? And then that one is just the squared value. So this becomes the cube root of 16 squared. So the value on top goes inside the square root, right? This value becomes your index, which is on the outside of the square root function. Okay, so far? Eight x cubed to the 1/4.
4 roots, and then to 8x to the
That's right. 4th root. 8x cubed. Okay. That's easy enough so far, right? So the denominator becomes your index value. The numerator just goes inside underneath the square root by itself with the value. Okay, so far? So now, let's take it the other direction. So we're going to work it backwards now. So the first one is the one I already did. Does that become?
6 is over
1/3?
6.
Okay. What's the index on this
Oh,
one?
wait,
CJ?
no.
Okay, what's the index though?
Or 2.
Yeah, that's right. You're right. Yeah. It is 2. Okay. So then, oops. How about this? Right? So I jumped a step. The last time I did it, I said this, correct? Right? And then what's 3 times a half? 3 over 2. Okay, so you're working it backwards. What about this guy? Cube root of 5 squared. Go ahead.
5 to the power 2.
3 over 2?
No, 2 over 3.
2 over 3.
2 over 3, sorry.
Which one is it?
3 over 3.
Okay, 5. That becomes your denominator, right? So first we're good.
Power 3 over t.
So nothing changes, even though I've added a variable in here, nothing changes. The rules still apply. Whatever's right here becomes my denominator on my fraction. So far? Okay, so don't let it change. Now, this is where I start to lose people. So I'm going to try and do this as slow as possible and make it work. No, first of all, any issues with this? Put your hand up if you have an issue with it. Yeah, Morgan.
I'm a bit lost.
What do you need to know, Morgan?
So that's just one question, right? Or is it a whole?
They're all different questions.
Okay, sorry.
So all you're doing is going from here to there in each case.
How do you do that? Like, how do you take 6? How do you turn it into? Where does the half come from?
This means a half as an exponent.
The exponent.
This means a cube root because there's a 3 in front of it. This is t root, so it goes on the bottom there. It's t.
So
Anytime you see this symbol, it can be written as a fraction in an exponent.
So it's the exponent divided by 2.
No. It means a square root, right? What does square root mean to you?
The square root,
So you gotta find a value that you multiply by itself to get you that number, correct?
right.
Okay, so that's what square root means.
Mm-hmm.
So if I have the square root of 4, what is the square root of 4? What number do I multiply by itself to get 4?
2.
You get 2, correct?
Mm-hmm.
Okay. 4, I could rewrite 4 as 2 squared. Do you agree with me?
Mm-hmm.
So that's the square root of 2 squared, right?
Mm-hmm.
That's also 2 squared to the 1/2 because this root value means 1/2 is a fraction.
So it doesn't matter if it's 6 or 8 or whatever, that's what it will be.
Mm-hmm.
Mm-hmm.
2 times 1/2 is that. That's why I get 2.
Okay.
Okay, you follow what I'm doing here? Sort of.
Yeah, mostly, yeah.
So because this was the cube root,
Yeah.
the 3 goes on the bottom of the fraction.
Okay.
Because this is the t root, the t goes on the bottom of the fraction.
So 3 is t.
No, 3 is not t. This root, t.
Oh.
Rewrite that as an exponent with a fraction. What is it? What's my base number there?
X.
Okay. And what is that as an exponent,
Cube. No, the square root, sorry.
right?
That's the square root of x.
It's the cube root of x.
Cube root, yeah.
What is that as an exponent?
1/2.
Square root is 1/2. What's the cube root?
1/3.
See a pattern happening there?
Yeah, that's it. 1/5.
Are you following me?
Yes.
So, r squared to the
1/3.
1/3, which means r to the 3.
It's
2 times 1 is?
1 is 2.
And it's 2/3.
2/3.
Follow me now?
Yes.
Okay, good. Okay. Anybody else want to question this? You okay? Okay. It's a good question asked by Morgan. That's it, dummy down right there. That's where I want it. I want you to nail this. If you nail this, then it just gradually gets a little bit harder. But you have to get to this first. You can't do this if you can't convert that 4th root to a quarter. Can't get there yet. Okay? Any other questions about this? Because I'm going to go into something brand new here. No? All right. My next question to you is this. What's the square root of 4? The square root of 4 is 2. Okay. What's the square root of 8? Okay. Not bad. Okay. Approximately 2.5 maybe, right? Somewhere in there. 2 point something?
It's like 2.2.
2 point, right?
Can I check?
No. First lesson, we don't want to use calculators if we don't have to. So, I have the square root of 8 here. I'm going to break down the square root of 8 because I want this to be a radical number. alright? And in order for that to happen, I want to take out the largest perfect square in the value and break it down. So the long and short of it is this. Is there a perfect square that goes into 8? What goes into 8 that's a perfect square? How many? 4? How many times does 4 go into 8?
Twice.
Goes into 8 twice? Okay, excellent. So I'm going to change this now to 4 times 2. Okay, don't write this down because I'm going to do way less steps than I'm going to show you now. Okay? So you agree with me that the square root of 8 is the square root of 4 times 2? Okay? This is new to you. I can separate those guys. Now I can multiply them as long as they're both under the square root, I can multiply them. I can't multiply them if one's in the square root and one isn't, okay? That's the first real rule that you need to figure out. What is the square root of 4? To rewrite this properly, I'm going to write it as 2 square root 2. So all I've done is I've taken out a perfect square out of 8, which was 4, and I've taken the square root of 4. So if you were to now, I don't want you to, use your calculator. Punch into your calculator the square root of 8. So this side of the room, punch in square root 8. That side of the room, punch in 2 times square root 2. What does the square root of 8 give me? Brittany?
2.828.
2.828. So again, we got to round it, right? Because it goes forever. What does 2 times the square root of 2 give me?
2.8.
Ah, same number, right? I haven't done anything to change the question. All I've done is put it in a form that is a little cleaner than 2.828. Okay? This, bless you, I call a radical. I have a whole number. This is called a mixed radical because I have a whole number and a square root value, an irrational number. Okay, want to try this again? Just so we have an idea. Do a bigger one. Alright, so what I'm looking for right now is a square root value that can go into. And when I say go into, everybody loses sight of what I'm asking. What do I multiply to get 50? What is one perfect square that multiplies by another number to get me to 50? That's what I'm asking. What is it? 25. What do I times 25 by? 2. Do we agree? 25 times 2 gives me 50. So then I can rewrite this as square root 25 times square root 2. Yeah? Root 25 times root 2 gives me root 50. What is the square root of 25? So how do I rewrite this at the end? 5 to the square root 2. Okay? So this is changing an entire radical into a mixed radical. So now what do you suppose I have to do next? Change a mixed radical into an entire radical. Okay, I'll do a bunch of questions with you so that we get used to doing this. But here's the next one. There's my mixed radical. I want to convert it into an entire radical. So in order to do that, remember what I just finished saying to you. I cannot multiply these two values the way they are. They both have to be under square roots. So how can I change the square root of 2 and put it, the value of 2 and make it a square root without actually changing it? Weird question, right? I want to change 2 so that it's under a square root, but at the same time, I don't want to change it so that then when I work it out, it's anything different than 2. All right? Yes, I could. Yes, I could. What would you think I should do here? Just square it. I can. and square root it at the same time. Right? Is that not right? So if I go like this, does that value still give me 2?
Yeah.
The square root of 2 squared, is that 2?
I would just,
Yeah.
maybe not just put 4.
Well, we're gonna get there. Okay? So does everybody follow what I did there? I squared my whole number and I square rooted it. Everybody understand that? So it's still the same numbers, 2. Right? So what is the square root of, well, what is this? This is 4, we agree? What's the square root of 4 times the square root of 3? Square root of 12. 2 root 3, written this entire radical is 12. Square root of 12. Okay? So you square the whole number and square root it. And then multiply it by the number that's already there, and you can rewrite it as an entire radical. Alright? Take a look at page 75. They go right in. You know what? Don't even bother. I'll do it. They go into some real complicated ones. Alright, so let's do this. 3 square root 2. Somebody tell me right now what they think 3 square root 2 is as an entire radical. What?
18.
18? Close. What are you missing?
Square root of 18.
Square root of 18. That's important. It's important, right? So how did we get that so fast? What did you do to the 3? Squared it and square rooted it, right? So that's like this. Fair enough? What is 3 squared?
9.
9. What's 9 times 2?
18.
There you go. Seems easy enough, right? Seems easy enough. Okay, I'm going to test you. Two, cube root 4. All right. Good. Still close.
Square root of 3. Cube root of 32.
Cube root of 32. Yeah. Yeah, you're absolutely right. Okay. So what did she do different this time than the last one?
Cube 2.
Cube to 2. So it becomes cube root of 2 cubed. Cube root 4. What is 2 cubed? 2 times 2 is? Times 2 is? 8. 8 times 4 is?
32.
Cube root 32. I said this to you last week. I put them all on the board up there. It's extremely important that you know your perfect squares and your perfect cubes. This is why we're here. Okay? You have to nail them because otherwise, if I rewrote this down as cube root 32 and I said, okay, break it down to a mixed radical, what am I now looking for? Well, I'm looking for a perfect cube that goes into 32. And then I have to work backwards. This way. Okay? Let's go. I'm just going to take randoms here. All right? Everybody, pencils out. Get going on this. 4 square root 5. Write it as an entire radical. No, I just want everybody to do it. Not asking for an answer. Just want you to do it. Who doesn't know where to start? Okay. Who doesn't know where to start? Morgan Cap, the only one. Is he? No? Don't know where to start? Okay. Who wants to tell me where to start? Tell me outside Rory. Rory's doing a great job, but everybody else needs to step up. Garrett. 4 squared. Okay. So I'm going to change this value. What is my goal here? I need to change it and put it under a square root. Now, in order to do that, if I'm going to take the square root of it, I'm going to square it as well so that I get it still remains as 4. So it looks like this. Here's your first step.
So you square it and then square root it?
Yes. Because if I take the square root of 4 squared, what do I get? 4. Right? They're the opposites, aren't they? You square something, you square root something, those are opposite each other, right?
Right.
So if I do that, I'm not changing it, it's still going to be 4, correct?
Correct.
Okay? 4 squared is 16, we agree? 16 times 5, Seth, did we figure it out? 80. Is that right? Okay, so what the mistake was? You just multiplied 4 times 5 instead of 4 times 4 times 5. Okay? Alright. Now we'll try. Emma? That becomes that, agreed?
And then 5.
Doug? What's 3 squared?
9.
9. 9 times 4?
36.
36. A problem with this, what is it? Not really a problem, but
Perfect square.
it is a perfect square, isn't it?
6.
So the answer would have been 6. Right? What could we have done right at the start of that question? Do we know the square root of 4?
2 times 2. Square root of 2. So you could have just got 2.
What's the square root of 4?
2.
2 times 3?
6.
6. Okay? Which we would have got from the square root of 36. Alright? Alright, let's make this a little more complicated now. Let's work the other way. We're going to work it backwards now. So now I'm taking an entire radical and I want to make it a mixed radical, which means I am looking for a perfect square that goes into 44. That's the first thing you want to identify. Is there a perfect square that goes into 44? What's the most obvious one? 22 a perfect square? No. I'm looking for just a very specific perfect square. What is it? What is it? 4. So instead of 22 times 2, what about 4 times 11? Is one of those a perfect square? So let's rewrite it as square root of 4 times square root of 11. What's the square root of 4? There we go. The part that I think confuses people is we keep working from one end and then we go back to the other end. Alright? Your objective in grade 10 is to be able to go both ways with this. In grade 11, there's a reason why. But in grade 10, right now, you just need to go both ways with it. This right here is what we need more of in grade 11. Going to break it down in grade 11. We work with radicals in grade 11. Okay? And in grade 11, we would take something like this. And add them together. Okay? That's grade 11 work. Grade 10, I just need you to be able to write in this form here. And then we eventually work through that in grade 11. Okay? So we gotta get this first part that we did today hammered out. Okay, I'll do a couple more. Okay, here's what I'm gonna do. I'm gonna do 7 questions, one from each of the first, from the assignment. Okay, I'm gonna do one from each, so that we get going on it and we understand what the gist is. So, starting with this, we want to rewrite this in radical form. 6 to the 3 over 5. I need to write it in radical form, meaning I want the root drawn out on there. What is my index value in this?
5.
What is it? 5. So where does it go? On the outside. So what is this? Fifth root x 6 to the cube. Okay? There's the first thing we learned today. Simply that. Number 2, rewrite this in exponential form, or as a power. What does that become?
3 to the 3
3 to the what?
3
3/4. Where does my index go on the fraction? To the denominator, to the bottom, that's right. So there's the second thing we learned today. Number 3 on that page is just basically your calculator. I'm not going to put it on there yet. Number 4. Rewrite a mixed as an entire. Rewrite the mixed as an entire. Just go ahead and do it. Write it down. Write it down. I need it all under the square root. Okay. Yeah, there's no add sign there though. That's a multiply. But you got it.
I don't need a calculator for this, right?
If you need it, go for it. I just need you to be able to do that. What's 3 squared?
9,
What's 9 times 5?
45.
Okay? How many of us got this right? Okay, who did not get it right? So I can have a look. Good. Good, good, good. Hello. Okay. Hi. Okay. Next. Okay. So far, everybody got that right? Am I under that impression? Okay. So now we gotta work the other way. So I'm gonna step it up a bit here. Okay. One more time, very similar. So now I'm not dealing with square roots, I'm dealing with the cube root. Sorry. What's the difference between the two? In the top one you did what? Squaring it, and the second one on the bottom you did cubing it. Agreed? So this should be cube root 2 cubed times cube root of 5. What's 2 cubed? 8. Cube root 40. Let's cube it. Why'd you raise it?
Oh. Did I erase them? No,
No, you don't. All right, last one. I want to write this as a mix. So what am I looking for now? What am I looking for? In order to break this down, what do I need to have? No. Perfect what? A perfect cube. So what is a perfect cube that goes into 48? 8 does. Is there anything higher than 8? What's 3 cubed? And 4 cubed? 64. Right? So that doesn't go in. So the only one that it can be is 8. And what do I times by 8 to get to 48? 6. What is the cube root of 8? 2 cube root of 6. Okay? 2 things that are going to be extremely important to you as you move ahead, and 2 things that you will struggle more than most with. Your multiplication tables. This whole thing is all about multiplication. So those of you that are fighting that and haven't got a grasp of it, I mentioned this last week again, if that's an issue for you, you should be practicing it. Because you can't do this without knowing how to multiply numbers to get to 48. It's necessary. And then you add in the second aspect of it, which is, do you know your perfect squares and your perfect cubes? Those are the 2 things that you need to know. If you can't do that, then you need to practice it. Can't stress that enough. And we should be. We should be practicing as a group. We will after spring break. We're going back to multiplication tables. And we'll do mad minutes, and we'll do some fraction work, and we'll do stuff at the start of class because it's imperative that you get that back. Too many of us have become calculator stupid, to be honest with you, without putting it any other nicer way. Okay, we rely too much on that calculator. All right, I'm going to shut the camera off because that's all we need to do new today. You have page 76 to work through. I will answer questions from the other 3 units as soon as the camera's done. Okay?